then 1 upon n plus 1 and so on up to 1 upon m. And because all terms are positive greater than 0, absolute value is same as this one. So you can, and what is Sn? 1 plus 1 half plus 1 upon 3 and so on up to 1 upon n. And all terms are positive, and this is number of terms larger than this get cancelled, and absolute value is same as the ordinary difference. So what remains is 1 upon n plus 1, 1 upon n plus 2 and so on 1 upon m. So absolute value of Sm minus Sn less than 1 upon 4, and left hand side is 1 upon n plus 1, 1 upon n plus 2, 1 upon m plus 1, and that must be less than 1 upon 4. But we know, but here n plus 1 is less than n plus 2 and so on m. So 1 upon n plus 1 is greater than 1 upon n plus 2 greater than so on greater than 1 upon m. So if I take each term here 1 upon n plus 1, no, 1 upon n plus 1 is greater than 1 upon m. So if I replace 1 upon n plus 1 by 1 upon m, then this left hand side, no, this is greater than, this is also greater than this one. So we have 1 upon n plus 1 plus 1 upon n plus 2 and so on 1 upon m is greater than 1 upon m plus 1 upon m plus so on 1 upon m. How many terms you have? N plus 1, n plus 2 up to m. Now this m can be written as n plus m minus n. M can be written as n plus m minus n. So this n plus 1, n plus 2, m. How many terms? 1, 2, 3 up to m minus n. So these are m minus n terms. So this will be equal to n minus n divided by m. So that is equal to 1 minus n upon m. So this sum 1 upon n plus 1, 1 upon n plus 2, which was left hand side Sm minus Sn. This is Sm minus Sn, which is same as modulus Sm minus Sn, and it was greater than less than 1 upon 4, and we have shown this is greater than 1 minus n upon m. Now this is true for all n greater than or equal to n 0. So I take m greater than n greater than or equal to 0. So in particular I take m equal to 2n. M equal to 2n. In that case this becomes 1 minus n upon 2n, that is 1 minus 1 half, that is 1 half. That means what we have shown, that this one Sm minus Sn is less than 1 upon 4 and Sm minus Sn greater than 1/2. Look here, result. This is less than 1 upon 4 and greater than 1/2. An absurd result. Now, you can't have any real number which is less than 1 upon 4 and greater than 1/2. So, a absurd result, so a contradictions. We have a contradiction. Why this contradiction happened? Because we assume that the given harmonic sequence is convergent. Therefore, our assumption that this is convergent is false, and therefore it is not convergent, it is not Cauchy. So, we have also this sequence now is not Cauchy, therefore not convergent by the Cauchy criterion for the convergence. Also, we have seen that these terms now get larger and larger, so it is monotonically increasing and positive. So, when it is not convergent and terms are getting larger and larger and there is no bound to it, it diverges to plus infinity. So, the harmonic series sigma 1 upon n, or if I take sequence Sn where Sn is 1 plus 1/2 plus 1 upon 3 so on plus 1 upon n, this is diverges. It is not convergent and diverges to plus infinity. So, this tends to infinity as n tends to infinity. So, this harmonic series, though divergent, it diverges to plus infinity. So, that means whatever real number you assume, now the sum surpasses that number. But interesting is this harmonic series diverges very slowly. It reaches to plus infinity, but very slowly, very deadly slow. You can see, suppose you say you take 1 upon n, 1 upon k, let me take k 1 to n, and suppose I want to make larger than say 10, the sum sigma 1 upon k, k 1 to n, if we want larger than 10, then you need 12,367 terms. So, n 1 upon k, k 1 to 12,367, then it crosses 10. The actual value comes to 10.04043073865553. So, just to cross 10 decimal number, you need 12,367 terms. So, you see how slowly it moves, it increases. Suppose you want this harmonic series, sum of that n greater than 20, then you need 27 crores 24 lakhs 600 terms. 600 terms, how large, na? Just to cross 20, though it reaches to plus infinity, but just to reach 20 you need more than 27 crores 24 lakhs 600 terms. And suppose you want this greater than 100, then n must be greater than 1.5 into 10 raised to 49. 10 raised to 49 means 49 zeros. Okay, so very, very huge number you need. So though the harmonic series sigma 1 upon n diverges, but it diverges very, very slowly, very, very slowly. Just as an application, will not go into the detail, but two applications I'll describe. So an ant crawls at the rate of 1 foot per minute along a rubber band, which is stretchable without any limits, and without breaking it. You can go on stretching it. So it is, you can uniformly stretch it. So it is infinitely stretchable. Suppose the rubber band is initially 1 yard, means 3 feet long, and stretch additional 1 yard every minute, at the end of every minute. If the ant starts from this end, crawling from this end, and it moves, we have given 1 foot per minute it moves, but every minute you stretch the rubber band 1 yard again, so 3 feet more. Now the question is whether the ant which started crawling from one end ever reaches to the other end of the rubber band. If no, why? If yes, just how and how long it takes. So 3 yards rubber band, yes, it reaches, and it takes for the ant 11 minutes. And here we have to use the way it crawls, and every minute you go on stretching the rubber band, then movement is the harmonic series, according to the harmonic series, and we have seen that how slowly it moves. So if you want this, which is greater than or equal to 1 yard, 3 feet, and ant moves 1 feet per minute, then for that you need 11 minutes. So after 11 minutes it reaches. The second applications, you are asked to walk to the end of an infinitely stretchable rubber road. Suppose road is rubber road, that is 1 mile long. After each step, the road stretches uniformly so that it is 1 mile longer than it was before. Every time, 1 mile longer. Before you took that step, assuming that there are 2000 steps a mile. 1 mile, suppose a mile, you need 2000 steps to a mile, and that you are moving at the space of 2 steps per second. Per second you take 2 steps. You will eventually reach, of course you will eventually reach the end of the road, which is 1 mile, but the approximate time in years that you will take is 3.455 10 raised to 860 years. You need years, means almost life of earth you need to cross over 1 mile. So this is the thing that harmonic series play a very vital and important role, though it diverges, but it diverges very, very slowly, very, very slowly. The second applications, third application, this is, let me define dn as the determinant as 3, 1, 1, 1 and so on. This is first row, 3, 1, 1, 1, 1, last is 1, 1, then 4, 1, 1, so on, 1, then 1, 1, then 5, 1, so on, 1, 1, 1, 1, and so on, so forth. Let me take one more, 1, 6, 1, so on, 1, and this continues. In that case, here 1, 1, 1 and so on. Last term is n. Now, you started with, these are diagonal elements, 3, 4, 5, 6 up to n. This is diagonal elements. So, how many rows and columns you have? You have 1 and 2 left out. So, 3 to n. So, it is n by 2 to n minus 2. So, here now let me how to expand this now, how to find the value of this determinant. For that, what I do, because it is difficult to expand this determinant, now what I do, from each row, from second onwards, that is Rj, from each row I subtract the first row for all j 2 to n. Now, in that case, what happens? Now, first row remains as it is. Now, second row